Welcome to homework.
We're asked to answer a question about chess using Euler and Hamilton paths. So a knight is a chess piece that can move either two spaces horizontally and one space vertically, or one space horizontally and two spaces vertically. So in coordinates, if you think of a knight at square xy, it can move to any of the 8 squares, x plus or minus 2, y plus or minus 1, and x plus or minus 1, y plus or minus 2, if these squares are on the chessboard. And they give a little illustration in the book to help with this exercise. So you can see the movements that a knight can make. Now, a knight's tour is defined to be a sequence of legal moves by a knight starting at some square and visiting every square exactly once. That's the definition of a knight's tour. A certain kind of knight's tour, called re-entrant, is if there is a legal move that takes the knight from the last square of the tour back to where the tour began. This might sound familiar, though we can model knight's tours using the graph that has a vertex for each square of the board, with an edge connecting two vertices if a knight can legally move between the squares represented by these vertices. In part A, we're asked to show that finding a knight's tour on an m by n chessboard is equivalent to finding a Hamilton path on the graph representing the legal moves of a knight on that board. Recall what a Hamilton path is. In a Hamilton path, we visit each vertex exactly once, moving along edges. This is obviously the same as a knight's tour, because in a knight's tour, we visit each square once, making legal moves. Therefore, this is equivalent. Okay, in part B, we're asked to show that finding a reentrant knight's tour on an m by n chessboard is equivalent to finding a Hamilton circuit on the corresponding graph. Well, this is the same explanation as in part A, except for now, a reentrant tour must return to its starting point. To the starting square. Similarly, a Hamilton circuit must return to its starting vertex. And therefore, process of finding a Hamilton circuit in this graph is equivalent to finding a reentrant knight's tour.